Hello, everyone. My name is Mohammed. I am from the University of Glasgow, and I'm here to talk about security and privacy in the 21st century. So, first of all, thank you very much for inviting me to give this talk today, and thank you very much to the organizing committee for organizing this workshop. So, I'll start by showing you a video. Now, what happens here is that a user enters a password on his phone. He enters a PIN. He leaves the phone on the table, interacts a bit, and then goes to get coffee. And in the meantime, somebody comes in with a thermal camera and takes a thermal image of the screen of the phone. And in the thermal image, you can see not only which digits were pressed, but you can even see the order in which they were pressed, because the most recently touched digit is the warmest one. So now the problem is that thermal cameras are getting much cheaper and easier to get and affordable. So you can get, for example, here in the UK, you can get a thermal camera from Amazon for £230. Once you get that, you can attach it to your phone, and then you have a thermal camera that you can use to perform thermal attacks. So this is a bit problematic, right? It's a risk, and you don't need a lot of technical skills to perform this attack. So one of the objectives of my research is to try to identify threats to security and privacy before the relevant technologies become ubiquitous. So speaking of ubiquitous technologies and ubiquitous computing, so in the 1990s, Mark Weiser wrote an article about his vision for the computer in the 21st century. He said we would have tabs, we would have pads, and we would have boards, and he described how they would look like. And actually, we've come a long way since then. So right now, we have smartphones, which look very similar to what he described as tabs. We also have tablets and laptops that look pretty much like pads. And we have public displays in malls and um, train stations and so on, from which we get the tickets, to the ticket vending machine and so on. And they are very similar to what he referred to as boards. And actually, we even went beyond that. So right now we have clothes that are interactive. We have smart watches. We have phones that are capable of tracking your eye movements and knowing where you're looking on the screen. And we also have phones that are capable of doing facial recognition. And if you showed this to someone like 30 or 40 years ago, it would sound very sci-fi, right? But then all of these developments are exciting, and they have a lot of benefits. But then the problem is that they also have implications on privacy and security. The problem is that these ubiquitous technologies, they come with strong computing power and a myriad of sensors. And then there are two challenges that come up here. First, non-tech savvy adversaries can use these technologies maliciously. So people who are not experts, you don't have to be a hacker, or you don't even have to know programming to use a thermal camera to know the password entered on my keyboard or on a touch screen. So that's the first challenge. The second challenge is that many of those ubiquitous systems that we are using today, they come with their own new security and privacy requirements, which are different than what we've been doing before. And one common mistake that we often do is that we keep on using the same ideas from previous systems for newer systems. Take passwords, for example, and we are using passwords for web applications, which is very it's completely unusable. You need to memorize lots of passwords because you have like, on average, people have like 200 accounts, and you're supposed to have a different password for each of those accounts. It has to have an uppercase character, a lowercase character, a symbol. It's not realistic to memorize that amount of passwords. And actually, the concept of a password or a PIN was established back when people used just one computer once a day, and they just needed to log in once a day. So we should try to avoid uh, falling into the same mistakes of the past. So to achieve this, my vision of having secure and privacy respecting ubiquitous systems around us, I think that we need to achieve two things. So first, we have to understand the privacy and security implications of novel ubiquitous technologies. And second, we have to actively secure and protect privacy of these systems without compromising their usability. And I stress here on usability, and I'll come back to this in a second. Um, uh, to do this, the way I approach this is by first trying to identify potential threats. And then the second step, which is a very exciting part, is to try to empirically verify this threat. And when I say empirically, I mean employing empirical methods like user studies, observations, questionnaires, and so on. And this helps us make sure that the threat actually exists. And not only that, it also helps us in better understanding the threat and the user's perspectives towards these threats. And I'll say in a bit as well in one of the examples that I'll discuss today, I'll say how this is the case. And then we start developing methods to overcome the threat. And then we start to evaluate the security and the usability of the methods that we are developing. And here, also notice that I said usability once more. So what's the deal with usability? Why is usability important in security systems? So to explain this, I'll give you an example from a hospital that a couple of years ago, they decided to have portable workstations like the one you see here on the left. And what happened is that, I mean, the reason they had it had a noble purpose. So the idea was that for doctors and nurses to be able to access the patient data through these computers instead of having to walk back to where the computer is stationed. But then because, it allows access to sensitive data, the engineers who built the system, they decided to have proximity sensors. The proximity sensor would detect when the user walks away from the workstation and then automatically locks down the system. And this requires the next user to log in once more. And the problem is that the proximity sensor was logging people off too frequently that they were so frustrated. So the nurses and doctors, what they did is that they started putting plastic cups in front of the proximity sensor to trick it into thinking that they are still around and thus avoid the system from closing down. Of course, in terms of security, this is terrible because this means that the data of the patients are exposed. Anybody who's passing by could have a look at private information about patients. But this is an example of where people's frustration with the usability of a security system led them to actually find ways to work around. So actually, the hospital then hired security personnel to go and collect these cups, which is, yeah, uh, I find it pretty funny. Um, so why did this happen? The problem is that actually people's purpose is never to authenticate or to log in or to perform any security measure. Their purpose or their aim is to retrieve some files or some information, right? But then if you come in and say, hey, I'm going to make it secure, I'm going to add a layer of security or a layer of authentication. The problem when you do that is that you start introducing a usability security trade-off. In many systems, we see that when you make them more secure, they tend to be less usable. And when you make them more usable, they tend to be less secure. But then actually, it doesn't have to be that way. We should aim to make systems both usable and secure. If you make it secure but not usable, what happens is like in the previous slide, I'm going back one slide here, what happens is that people will work around it. They will find ways around it. And it's perfectly reasonable to do that because they actually, their aim is to just get their job done, get the data about the patients, for example. So to make it secure and usable, you need to include the security and usability both from the beginning of the design process and then iteratively build the system instead of actually thinking of usability and security as an afterthought or something that you build on top of a system that is already existing. And remember that a system that is not usable is not secure. If you build something that is very secure, but it's very difficult to use, people will not use it properly, or they might not even use it at all, and you end up with less security. I like this quote from the National Cybersecurity Center in the United Kingdom, and they say that security must work for people. If security doesn't work for people, it doesn't work. Take a look at this example here. Would you ever lock this door? Probably you'll never do it because it's very difficult, right? So what's the point of having a security system if people don't use it or work around it? And then to further emphasize the importance of usability, let's take a look at an example. Let's say that you unlock your phone in 1 second, right? Now, somebody comes in with a more secure method for unlocking your phone, but it takes 6 seconds. So, usability security trade-off. So they might say, okay, well, we have to reduce usability because we're improving security. This is wrong, by the way, but let's just assume that this is the case. So they added 5 more seconds. Now, people on average unlock their phones 40 times a day. If you add 5 seconds to each time they authenticate, then you're adding 200 seconds a day for authenticating or unlocking your phone. If you multiply this by the number of days in the year, you'll find that we would be spending more than 20 hours every year doing nothing but unlocking your phones. And then in 60 years, you will have spent more than 50 days of your life unlocking your phone 24/7. If you multiply this by the population of the world, you will find that humanity lost a significant amount of time just unlocking their phones. So this is why usability is key. So back to the four steps. So the first two steps, they're focused on understanding threats to privacy and security, while the other two, they're focused on creating systems to protect privacy and security. I'll talk about examples of work that we did in both directions. So let's get back to the thermal imaging project. So this was a paper at CHI 2017, and the reason actually thermal attacks work is that we humans are warm-bodied creatures. When we touch interfaces or anything basically that is not as warm as our bodies, what happens is that heat is transferred from our body to that surface, and these heat traces can be tracked using a thermal camera. Now, from that, we actually observed that there is a threat of using thermal cameras against people's security, right? So we identified the threat, and then the next step was to try to empirically verify the threat through a user study. So we ran a user study. We invited participants to our lab. We asked them to enter a list of pins and patterns that we gave them on a mobile phone, and we took thermal images of the screen after they've entered their passwords. And then we experimented with things like properties of the passwords and the age of the heat trace. So because if the heat trace stays too long, it starts to decay over time. So we wanted to see for how long our passwords actually trackable from a touch screen. And then we measured the distance between the guesses that we are able to make using the thermal camera and the actual passwords, and the success rate of the attacks. When thinking about the properties that could make pins stronger or weaker against thermal attacks, we thought of experimenting with duplicates, because as you can see here in the thermal image in the middle, if you have just one duplicate, it actually makes the heat traces look different, and it might actually make it difficult for an attack to take place. And in terms of lock patterns, which are popular on Android, we thought of experimenting with overlaps, because if you have an overlap, the heat traces at this point are actually distorted a bit. So we thought this could also be important when trying to understand the impact of thermal attacks. And then we experimented as well with the age of the heat trace. So we took thermal images at different time intervals after authentication. And then let's take a look at the results. So actually, contrary to what we thought, we found that duplicates actually make passwords weaker against thermal attacks. And it turns out that if you actually take a thermal image of someone's touches on a screen, you can distinguish that they're actually touched twice or three times. Usually people are very unlikely to press the exact same set of pixels every time. So you can notice this difference. And even if you don't, you would end up with very few variations in the password, which significantly reduces the password space, and this allows attack to take place. So in the first like 15 seconds, we could recover the vast majority of passwords. Sorry, in the first 30 seconds, we could do it. After 30 seconds, the heat traces started to decay, and finding the passwords became harder. For lock patterns, it was actually the other way around. So overlaps actually made passwords significantly more secure. So just having a single overlap is already makes thermal attacks much harder. If you don't have any overlaps at all, it's actually much weaker against thermal attacks. Right, so now we identified the threat, we empirically verified it. The third step is to develop methods to overcome the threat. And actually, just through our study, we're able to find out that patterns with more overlaps or pins that are longer, they're already more secure. So you can see here that the empirical study actually told us how to resist thermal attacks. But then actually, there are also other approaches from previous work. So we recently published a paper in CHI 2020 about eye gaze, how you can use your eye movements to authenticate or to protect your privacy. So there are many applications of eye gaze on for security applications, and and actually, it's pretty exciting now because you can track the eyes today on mobile phones and so on. And this could be used for authentication and privacy protection and so on. So for example, this is a scheme where you can authenticate by touching the screen and looking to the left or to the right. There are things like biometric authentication, which are also promising alternatives that are secure against thermal attacks. So that was one project. The other project I wanted to talk about is shoulder surfing. And shoulder surfing refers to the idea of someone looking at someone's phone or screen without their consent and uncovering private information. Now, the problem is that this threat was assumed to exist, but it was never confirmed through empirical studies. So if you look at these four steps that I described earlier, you'll find that the step 2 is actually missing. So we decided to investigate this. We ran a questionnaire where we collected responses from 174 participants, and we asked them about their experiences of shoulder surfing. So whether we actually asked for experiences as users who are victims of shoulder surfing and observers who are actually people who performed shoulder surfing. And we had some challenges because, of course, nobody wants to tell us that they're observers or shoulder surfers, but we managed to get people to fill the questionnaire because actually we tried to frame it in a way that it's not intentional, that we understand they're not evil or anything, and we actually got a lot of interesting responses. The first thing we noticed is that we got much more responses from people who are observers than people who are victims of shoulder surfing, and this implies that actually shoulder surfing happens a lot, but it's not actually noticed by the user in most of the cases. Out of the 84 stories that we collected from observers, only 6 of them said that the user noticed them. So this suggests that people are actually less likely to notice being shoulder surfed. We also found that shoulder surfing of non-private content could be privacy invasive, and it could have dangerous consequences. Um, the paper was published in IndiaHCI 2017, if you want to take a look at that in more detail. But one interesting finding here is that although the vast majority of research done again in shoulder surfing focused on shoulder surfing against authentication or credentials, we found that the majority of shoulder surfing situations in the real world involve text and not credentials as previous work focused. So this motivated us to look into protecting text instead of just protecting authentication or credentials from shoulder surfing. So for example, we developed this system which lets you like hides the screen except for the parts that you're looking at using eye tracking through the camera of the mobile device. But then we also looked into things like ways to protect security in case of credentials. But I'll skip through that today because of the lack of time. Um, uh, Before I conclude, I wanted to talk about one last project where we looked into creating security protection systems. And I'll talk about this project about authentication in virtual reality. So this category of projects focuses on trying to solve problems. So the first one was trying to understand the problems, and then now we're trying to solve problems or address them. So now we are starting to have more and more virtual reality applications. Like there's, for example, Facebook Horizon, which is the new virtual reality alternative for social networks. And then there are many cases where you would need to authenticate in virtual reality to verify your identity or confirm purchases or so. Um, actually, interestingly, we did this study in 2017, and this method over here was found by our study to be the most secure and usable one. And actually, right now, it's being used by Oculus in their authentication page. So that was pretty nice to see that they hopefully used our results. Um, so actually, if you try to replicate authentication methods in virtual reality, one problem is, like you see here, by looking at the people who are entering passwords, you can see what their passwords are. So we tried to come up with ways to overcome this. So here we already identified a threat. We found that people entering passwords in in virtual reality could be observed from the outside world, and you could actually find what their passwords are. And we actually conducted a study to empirically verify this threat, and we found that 18% of passwords could be observed from the outside world. So we started to develop methods to overcome this threat, and then we developed this concept where you authenticate in virtual reality by looking at virtual objects in a certain order, and this would constitute your password. The paper is published in AVR in 2020 if you want to take a look at it. Great. So to conclude, there are three main takeaway messages that I like um, to leave you with. So first, we need to anticipate how ubiquitous technologies could be used maliciously and then proactively design methods to protect users from these threats. And then we need to do empirical studies to allow us to better understand the threats and the user's needs. Remember that it's very easy to design for security protection without usability in mind. But the more important question is how to design security and privacy protection that are usable and easy to use. So with this, I conclude my talk, and feel free to get in touch if you want to discuss any of those ideas or concepts. And I was asked to prepare questions to the audience. So I encourage you to start thinking about these questions. So, what are technologies that are becoming ubiquitous today and may have malicious uses, and how can we protect people from their malicious uses? And second, now we are all working at home, and we are starting to witness some changes in our lifestyles. So actually, now we're starting to use also virtual and augmented reality technologies at home. So what are the possible dangers of, in terms of privacy and security, of using VR and AR technologies at home? And assuming we, like in the future when the COVID situation is better, now VR and AR technologies are also starting to become publicly used in public areas. So what are the privacy and security issues that could occur then? So with this, I'd like to conclude. Thank you very much, and looking forward to the discussion.